units of my magnetic dipole moment as units of amps times meter squared. Okay. And we see that it's divided through by 1 over meters cubed. That's the dimensions of element volume, which gives rise to amps per meter. Okay. So now we are working on a macroscopic level as compared to a microscopic level. And this is a representation of my averaging process. Now let's go back and look at our laws. One law that we've been working with is the curl of the magnetic vector potential on the magnetic flux density at our point of observation divided by the permeability of free space. This was identically equal to the current densities that exist in a small volume element about my point of observation. And this is a current density. And this is a current density which we will now reestablish as being a current density due to free currents. Because Ampere's law that we have posed was in free space. Which means that there is no materials present, and since there's no materials present, there is no magnetic dipole moments. So we will denote this as a free current density. Now we're going to go and look at another law, and that is the Lorentz force law. Recall that the force on a charged particle in the presence of the electric field and the magnetic field is equal to charged particle times the electric field plus the motion of that charged particle times its charge crossed into the magnetic field, or the magnetic flux density. And we call it, this was our Lorentz force law. In the Lorentz force law, we have Coulomb's law. That's the first term. And here we stated that the electric field is the resultant field due to free charge and bound charge. Both contributions are taken into consideration, and that makes perfect sense because we're looking at the resultant force. This then tells us that in order for our system of equations to be equivalent, that B must be a resultant magnetic field. generated by both free currents and we will now identify the currents associated with an atom or molecule as being a bound current because that charge, motion, is bound to the atom and molecule. It doesn't flow freely inside the material medium. Consequently, we now modify Ampere's circuitorial law in free space to be Ampere's circuitorial law in a space that's valid internal to a medium that has magnetic properties.